Okay, students, as we have done that a current carrying conductor produces magnetic field around it. Okay, and this was verified by Oersteds, a scientist. It means whenever current is passed through a conductor, magnetic field will always be produced around it, and we should have any device which can sense that magnetic field. Means magnetic field is there, but we need a device to sense it. So we have this compass needle. So compass needle is also a magnetic needle. It is also made up of magnet. One end as north pole, other end as south pole. Such as it always points along Earth's north and south direction. Generally it points along Earth's north and south direction. Why? Because Earth itself behaves like a huge magnet. So it points along Earth's north and south direction due to magnetic attraction of its ends. And it is being used for so long by many persons, like to go from one place to the other place by ship or by a plane, and this was the way. In the earlier times, this was only the way to determine the direction. Nowadays, we have so many other ways, like we use satellites to determine the directions, navigation. But still, this magnetic needle, compass needle, it's a very useful way to determine the direction of north and south pole of Earth using the magnetic attraction. Okay, so this is a compass needle. Now, at this time, this compass needle is pointing along Earth's north and south direction. Clear? At this time, because there is no other magnetic field is present, because no current is flowing. I have switched off this battery. Battery is not switched on, so current is not flowing in the circuit. So as current is not flowing, it means this compass needle is pointing along Earth's north and south direction. But when I will switch on the battery, current will pass through the wires and through this coil also. Then magnetic field will be produced around it, and that magnetic field will be sensed by this compass needle. This compass needle will experience force, and hence it will rotate, it will deflect, and the deflection produced in the compass needle will show that there must be some magnetic field around it. That's why this compass needle has experienced force and it starts deflecting. Let's see how it occurs. So I have this battery. I will switch on the battery and you will note down the deflection produced in the compass needle. Look, the deflection is produced in the compass needle. It means this deflection is produced in the compass needle because of the magnetic field produced around this coil, around this wire. There is magnetic field, and due to this magnetic field, compass needle experiences force, and due to that force, compass needle shows deflection. So this was the experiment shown by Oersteds, in which it was proved that a current carrying conductor produces magnetic field around it. Okay, so this was the all about the magnetic field around a current carrying conductor. And now, if I want to talk of the direction of the magnetic field, what is the direction of magnetic field? Students, if you want to find out the direction of magnetic field around the current carrying conductor, like this current carrying conductor, like we said, the current is flowing in this wire. Okay, this is also a wire around it, current is passing through it. Now I want to find out that what will be the direction of the magnetic field. Look, now this is the positive terminal of battery, and current is coming out from this wire and it is moving in this direction. So here it is north and it is south. It means current is flowing from north to south. Current is flowing from north to south. Let's see, at this direction there is east and here is west. Let us see where should be the deflection, what would be the deflection, direction or deflection produced in the compass needle, due to which now it should be free to move. Okay, it is free to move. Now we have to find out what is the direction of the deflection produced in the compass needle when the current flows from north to south. Okay, let's see. Look, It means deflection of the compass needle, this north pole. This north pole, it deflects towards east. This north pole deflects towards east. North pole of this compass needle deflects towards east when current flows from north to south. That it was shown clearly. It was clearly shown. You can again see the deflection. Look. So it deflects in this direction towards east. It means, so there is a rule in which we can determine the direction of deflection. The rule is called snow rule. According to this rule, when the current flows from a wire from south to north, here it is flowing from north to south. So when the current flows from south to north, then the north pole of the compass needle will be deflected towards west. But here the case is opposite. Here current is flowing from north to south, so the north pole of compass needle deflects towards east. Okay, so this was the rule to determine the direction of the magnetic field produced. Thanks.